So in all the average rate of change problems we've seen so far, we've had two different x values given to us. And that's not any different in this example. However, in the previous examples, those two x values were both numbers. In the examples in this video, what you'll see is they don't have to be numbers. They could be expressions. And we'll see why later. Formats like 2 and 2 plus h end up being really useful. But without even worrying about why we're doing this, let's suppose we were asked to figure out the average rate of change of this function f of x equals 100 minus 4x squared, which is the one we investigated in the intro video of this section, where the two x values, instead of being 2 and 5, are 2 and 2 plus h respectively. Well, let's see. Our average rate of change formula tells us the average rate of change of some function f from x1 to x2 is f of x2 minus f of x1 divided by x2 minus x1, the slope of the secant line if you want to think about it that way. So to figure out the average rate of change between these two strange x values, I just need to know what are their two corresponding f of x values. F of x1 I would get by putting 2, which is what x1 is equal to, into this function f of x. Well, let's see. I guess that would be 100 minus 4 times 2 squared, a calculation that I think I already did in a previous video. 2 squared is 4. 4 times 4 is 16. So it's 100 minus 16, or 84. Right, but what about f of x2? That's going to be way harder. Well, kind of, but not really. All we're going to do is put x2 into this machine. x2 is an expression, 2 plus h, but we've already learned how to put expressions into machines. All you do is copy the blueprint and change all of the input, the letter x, into whatever the expression is, 2 plus h in this case. So I would have 100 minus 4 times 2 plus h squared. Because I'm putting an expression into this machine, what's going to come out of the machine is also going to be an expression, meaning there's going to be h's floating around, and that's okay. However, a little hint, the reason we're putting in these strange expressions in the first place, as I'll explain at the end of this video, is to do some algebraic simplification with our final answer. And that algebraic simplification will be a lot easier if you expand this to the point where there's no parentheses. So you don't know that at this point, but I'm telling you that it's going to make your life easier if you get rid of all the parentheses here. So how could you get rid of the parentheses? Well, 2 plus h squared, I could expand that binomial. I'd have 100 minus 4 times, and then instead of 2 plus h squared, I could write 4 plus 4h plus h squared. If you have a hard time seeing where that comes from, here's those steps up here in green. Now my parentheses aren't squared, so I can get rid of the parentheses by taking this negative 4 and distributing it through. I guess that would give me 100 minus 16, the negative 4 times the 4, minus 16h, the negative 4 times the 4h, minus 4h squared. You could stop here because we've gotten rid of all the parentheses, but you might as well combine like terms and recognize that 100 minus 16 is 84. So a better, in some sense, answer than leaving your expression like this is to write your answer as 84 minus 16h minus 4h squared. And I say answer, really what I mean is the output of this function f when we put 2 plus h into it. That's not really the answer to the question. The question asks us to figure out the average rate of change. So what we have to do is take our 4 pieces of information, the 2 x coordinates and the 2 corresponding f of x coordinates, and plug those all into this expression. So f of x2 is 84 minus 16h minus 4h squared. And from that, I want to subtract f of x1, which is 84. And then in the denominator, I have x2, which is 2 plus h. And from that, I want to subtract x1, which is 2. I guess you could leave your answer like this, but typically people don't. They simplify. This 84 minus this 84 cancels out. So in the numerator, I have negative 16h minus 4h squared. And in the denominator, this 2 and this negative 2 cancel, so I'm left with just an h. Because each term in the numerator has an h in it, and I have an h in the denominator, I can cancel out one of these h's and one of these h's with this h, and what I end up with is negative 16 minus 4h. And that would be the best possible final answer. I know from experience that it's pretty frustrating for students to see this as the answer and be like, what does this mean? Like, why did I do all this? This feels like a problem that a teacher made up with no reason other than forcing a student to do a lot of algebraic manipulation and simplify expressions, right? Why would you ever want to put 2 and 2 plus h into this machine? Why would you care about the average rate of change between these two kind of weird abstract points? The short answer is calculus. If I go back to the graph of this expression that we looked at in the first video, In Math 111, we're interested in the average speed of the rock between two different points. So like between time 2 and time 5. But in a calculus class, that's not what you're interested in. In a calculus class, what you're interested in is the instantaneous speed, not the average speed, but the instantaneous speed at one point. So rather than find the average speed at 2 points, we want the instantaneous speed at 1 point. Instead of finding the slope of this secant line, in a calculus class, what we want to do is find the slope of this tangent line, a line defined by a single point, not two different points. And you're like, wait, slope's really easy. You really wait until calculus to do that? Yes, because to figure out the slope, you need two different points. But this tangent line is defined by a single point, not two different points. And if you try using this single point, 284, as like the two different points in your slope formula, you would have 84 minus 84 divided by 2 minus 2. You'd have 0 over 0. And since you can't divide by 0 in math, you wouldn't get any information. It's really challenging to figure out the slope of a line if you only have 1 point on that line. But there's a little trick you can do. And the trick is one that you learn in calculus. And it's kind of cool that we can see that trick at this point in our Math 111 class. Really what you do is you say, no, I don't want to use the same point twice in my average rate of change formula. That wouldn't make any sense. I'd get 0 over 0. I'm going to use two different points. One of the points will be this point 284, and the other point will be some point, I don't know, maybe I can picture it right here. And it's not 2, it's 2 plus a little bit more. We'll call it 2 plus h. Well, if its x coordinate is 2 plus h, then its y coordinate would be f of 2 plus h. And since we have two different points, this one pictured in pink here and this one pictured in pink here, we can calculate the slope of the line that connects those 2 points, the slope of the secant line going through these 2 pink points. And you're like, yeah, great, but that's not the line that I'm looking for here in pink. Right, but by keeping h as a variable, I can later change that h into a 0. Because if I change this h into a 0, then 2 plus 0 is just 2. I use this same point twice, which gives me this tangent line. What I'm saying is when you take a calculus class, what you will be interested in is not the average rate of change, but the instantaneous rate of change. Not between two different points, but at a point, like at the point 2. And the way you'll figure out the instantaneous rate of change at 2 is you'll pretend you're figuring out the average rate of change between 2 and 2 plus h. You'll go through all these same calculations that we're doing. We'll get this as our answer, and then we'll be like, really, I don't want a secant line, I want a tangent line. So I want these to be the same point twice. So I want to make h equal to 0. So after I do all this algebraic manipulation, I go changing all the h's into zeros. I get negative 16 minus 0, which is just negative 16, which is the answer in a calculus class. This is not a calculus class, so you stop at this stage where we have negative 16 minus 4h as our answer. But I just felt like if I didn't explain why we wanted this answer in the first place, how incredibly powerful this answer ends up being in a future class, you'd be really frustrated by me asking you to do this. And since I'm going to ask you to answer questions like this a lot in this class, I wanted to explain why I'm doing it. Let me show you one more example. Here's a new function, f of x is equal to x squared minus 3x plus 4. And I'm given two different x values, maybe I'll name them x1 and x2, that I'm trying to find the average rate of change in between. And note that they fit the same format where x1 is some number, 3 in this case, and x2 is that same number plus h. This is something that's really useful in calculus, but in Math 111, they're just expressions that we're going to throw into these machines. I need 4 things for my average rate of change formula, 2 outputs and 2 inputs. The 2 inputs are given to me right here. To figure out the corresponding outputs, I start by putting 3 into this machine. That's easy enough, just copy what I see here, except change all the x's into 3's. So I got 3 squared minus 3 times 3 plus 4, 9 minus 9 plus 4, I think that's equal to 4. And then I take 3 plus h, and I put that into the machine. So I would get 3 plus h squared minus 3 times 3 plus h plus 4. If you're not worried about simplifying, you can leave your answer like this, but my friendly little hint for you is you're going to be worried about simplifying, so you might as well get rid of the parentheses in this stage. First, expand this binomial, so think FOIL, to get 9 plus 6h plus h squared. Then take this negative 3 and distribute it through these parentheses, so you get negative 9 minus 3h. It's really easy to make this positive, but it should be a negative, because it's negative 3 that you're distributing through the parentheses, plus 4. And then combine like terms. I got 9 minus 9 plus 4, so it sounds like I got a 4. I got 6h minus 3h, so I guess I have 3h, and then I have this h squared. F of x2 simplifies to 4 plus 3h plus h squared. Now that I have x1, x2, f of x1, and f of x2, I can go plug in those into this average rate of change formula. F of x2 is 4 plus 3h plus h squared. From that, I want to subtract f of x1, which is 4. In the denominator, I have x2, which is 3 plus h, minus x1, which is 3. You'll note that these follow kind of a similar pattern every time. The 3 and the 3 in the denominator cancel, so I'm left with just an h. And each of the terms in the numerator that don't have an h in them cancel out also. So I have 3h plus h squared. I can cancel an h from each of my terms in the numerator with the h in the denominator, and I'm left with 3 plus h as my final answer. If this were a calculus class, I'd take it one step further and change all the h's into zeros. But this is not a calculus class, so I stop right here. This is my final answer, and I'm done. If you want more practice with these, I have more examples that you can do. Here's another average rate of change formula where I have expressions 1 and 1 plus h, just a different function this time. So we're kind of dealing with functions that sort of produce things that look like fractions instead of polynomial functions like you see down here. Or if you want even more algebraic practice, this first example that we did, instead of doing 2 and 2 plus h, we could do a and a plus h as our two inputs. If you want more practice, you can work on those, but I think by following the examples that I did in this video, you've learned everything that you'll need to know for this section, so I'm gonna call this video good here.